intentar
we want
cuantificar la
to know,
información para que esa
we want to
información
quantify that information
proveerla al rehabilitador,
to
al
make
fisio
it
o al
amenable
clínico
to the
para intentar
rehabilitator,
tener
to the clinician,
más información o una ayuda a ver
in
qué es
order
lo que
to
está pasando
have
con la
more,
actividad de los
to
diferentes músculos que pueden estar
get some
implicados
help
en la
from
enfermedad,
that
en la discapacidad o en
recording
el desorden
to see
neuromuscular.
which is the disability
Pues
affecting
variables
that
de interés
individual.
que podemos calcular
And this is what we can
mediante
do.
un procesado de menos a más sencillo, de más sencillo a menos sencillo, puede ser
From
variables
more simple
referentes
to
al nivel de
more
energía o amplitud de
complicated,
la señal, que nos indicará, por ejemplo, el nivel de reclutamiento de
the level
unidades
of
motoras
recruitment
en
of new motor
sostenida,
units,
como puede ser el valor medio
the
rectificado o el
rectified
valor
average
cuadrático medio.
value, the average
Después cambios en
quadratic
la velocidad
value,
de conducción
changes in the
o en la
conduction
frecuencia de activación
velocity
de las unidades
or in
motoras
the
activas
frequency of activation
influyen
of
en la
active
información espectral
motor
de la señal,
units,
como puede ser la compresión o la expansión del espectro,
compression or the
y eso lo podemos detectar con
expression
la
of the
frecuencia media o la
spectrum.
frecuencia mediana, o incluso la
This
velocidad de
can be
conducción
recorded by means of
mediante el
the
retardo de
average
esos potenciales
frequency
que
or
veíamos
median
entre un canal y
frequency,
otro,
and
sabiendo
also
conocido
the
cuál es la distancia
retardation
entre los.
between channels, the delays between different neighboring channels.
Muy bien, como aplicaciones clínicas,
Microphone, please.
tenemos aplicaciones en trastornos del sistema nervioso central.
For us to clinical applications, we have applications in the CNS, in disorders of the CNS. Also, the peripheral nervous system, we hear very poorly. We can look at obstruction. Now, they have been switched off, both of them. I'm sorry, both. Se han apagado los dos. Que le pase el otro, que le pase el otro. Pásale el otro micro. Sorry about that. Oh, here we are. This sounds better.
Bueno, como decía, para
As I was saying,
conocer patrones de activación muscular.
One of the main interests is to look at the anatomy of the muscles, as mentioned earlier. In the muscles, there are several innervation areas, and one of the possible applications is during labor and delivery. For instance, if you do an episectomy, the doctor may know exactly where the innervation areas are, in order to plan where to make the cut and to prevent any urinary incontinence. Also, during rehabilitation processes of patients who had some cord lesion or brain lesion, we will know exactly the motor units and the innervation areas. Thus, we can monitor any changes taking place in that individual. Additionally, we can understand better the structure of muscle fibers. We can look at the geometry of the muscle, whether the muscles are in parallel or in series, the attachment with the tendons, how far the muscle goes, and this is all related with the strength that the muscle can create, the force. By way of an example, let me show you this study which we did on patients with lateral epicondylitis. We looked at the wrist isometry in 3 muscles: the radial muscle, the extensor digitorum, and the extensor carpium lax. As you see, there's a difference between healthy subjects and patients. In healthy individuals, contraction is for the carpus radialis, whilst in patients the contraction is sustained by the extensor muscle. Differences were also found in the participation of these muscles in the same contraction process, being greater in the healthy individual. In the case of the patients, the MCV was more prominent. This shows up a muscle imbalance which may be caused by the overuse of muscles in lateral epicondylitis. These This disorder causes repetitive contractions, and these repetitive contractions generate a change in the pattern, which ends up with a lesion, which ends up being a tendinous lesion. Additionally, we look at myoelectric fatigue during sustained contraction, expecting the CNS to recruit a greater number of slow fibers, slow twitch fibers. It is expected that the conduction velocity of the fibers will diminish, as well as other variables, which are the frequencies. In this case, we have an isometric contraction of the hand. We draw up the fatigue diagrams looking at the evolution of the classical parameters in time. And we define the indices as the slope, the linear slope of these parameters. In the case of healthy subjects, the significant index for conduction velocity is this. Whilst in patients, we see different results, and in both populations, we see that the fatigue index is greater in patients than in the healthy. And again, these are patients with lateral epicondylitis, which is usually understood as a tendinous lesion. This is also useful for isokinetic exercises. We use these isokinetic exercises to see the variation of the muscle pattern in different degrees of movement. For instance, we see a greater activation of the flexor muscle and of the extensors during extension, but we can compare the different patterns. Finally, the detection of and classification of motor units is also important in order to understand how the CNS works. So we need to identify within the signal the different motor units which are active. Once you've got the active units, you have to classify them in order to know how many there are and what shape do they have. You can look at duration, amplitude, etc. Looking at this one here, for instance, we have 4 classes plus an outlier, a huge outlier. The outliers are superpositions of different potentials, and they are more complicated as the signal becomes more complex. Usually the classification isn't very simple. This slide, for instance, shows 2 simulated signals with 5 motor units and 3 motor units. There is a clear difference in the groups, suggesting that the classification is simpler. But in 5 motor units, the potentials blur or merge together, and it is very complicated to tell them apart, to tease them apart. So it's pretty difficult. When there are very many motor units, the whole thing becomes complicated. So by way of conclusions, we've shown you the mechanisms which generate and control voluntary muscle contractions. We've looked at the different variables in the MG signal and the different pathologies. When we've presented an example of application in patients with lateral epicondylitis, we've seen a difference in the pattern of muscle activation and higher rates of fatigue in these patients. And now we will run a short demo in order to acquire a signal, I believe she says. Microphone, please. We need a microphone for the speaker. I believe he's saying that he's going to use a matrix, a linear matrix.
es el que nos va a permitir.
I believe he's saying that he's going to put the linear matrix on the hand to see the potentials.
Cada ventana de visualización hemos observado apenas
For each visualization window, we've seen only 40 milliseconds. We see how the potentials begin to appear. It's a relatively short period of time. This is 1 second. The signal looks very noisy, but then we can see how the potentials propagate, and even the appearance of some innervation area or innervation zone.
Podemos ver aquí, tú misma.
En este caso, por ejemplo, vemos que en esta zona hay una zona de inervación.
There is a zone of innervation.
La propagación de estos potenciales, el signo. Mientras que en este otro sentido
Whilst
hay
in
otro.
this
Y aquí
point here, there is another one.
ver cómo en el
And
tiempo
we can see
se va
that in the course of
desplazando
time, there's a shift or a displacement
desde el punto de inervación hacia los
from the
tendones
point
que
of
estarían
innervation down to the
en
tendons,
los extremos.
which would be at the ends of the muscle.
Gracias por su atención.
Thank you for your attention.
Muchas gracias por la presentación.
Thank you very much. Very interesting paper.
¿El público tiene alguna
Are there any
pregunta en estos
questions for
momentos?
our speakers?
Pues a mí me gustaría hacer una.
I'd like to
y
ask you one.
¿Tienen previsto alguna aplicación práctica
Is there some
ya
sort of
con
practical
pacientes
application
de
with real
justamente las técnicas que
patients?
están realizando?
Bueno,
Well,
nosotros en concreto aquí hemos mostrado la
we've
aplicación
shown you the
de
application
un proyecto en colaboración con la mutua EGARSAT,
project with
Egara,
Mutual.
en Tarrasa, que
This is a
justamente
Tarrasa,
querían implantar o utilizar estas técnicas para monitorizar el proceso de
health
rehabilitación
management
de pacientes
organization
con epicondilitis,
to work
que
on
es debido a
patients with
desórdenes neuromusculares
epicondylitis.
por
These
una
are
función repetida, como
These are
explicaba Mónica,
repetitive contractions
para
leading
diseñar
to the
también
problem.
ejercicios más
To
adecuados a los
design
procesos de
better
rehabilitación. Y con otros
exercises for the
hospitales estamos en
rehabilitation.
colaboración
And with other
con el Clinic,
hospitals,
por
we are
ejemplo,
working with a
para el tema
hospital
de
clinic
dolor ortostático, personas
for
que
orthostatic
cuando están de
pain,
pie
people who
empiezan a
when
temblar,
standing
cuando
up,
están estáticas
they
y de pie
begin to
empiezan
tremble.
a temblar sus
They
extremidades
tremble a
inferiores,
lot.
lo que impide
The
pues,
lower
el
limbs
desarrollo de
cannot
ciertas
be
actividades
controlled,
laborales,
so
en
they
la vida,
cannot work in
etcétera.
certain
O
places.
en concreto también pues, en el Instituto Goodman,
Or for the
pacientes con
Goodman
lesión medular
Institute,
incompleta, hemos realizado algún
with a
estudio, etcétera,
complete
para
cord
monitorizar
section
procesos de rehabilitación de la marcha que los
for
sistemas
gait
hospitales
rehabilitation
están llevando a
processes
cabo los pacientes, por
and
ejemplo, entre
others.
otros, ¿no?